I'd now like to talk about hydrogenation using a poison catalyst. Now with the poison catalyst, what we're talking about is hydrogen, palladium, and in here you're going to have calcium sulfate and quinoline. I want you to contrast that with the previous one where we've just got hydrogen and palladium. Now we've just got hydrogen and palladium. What happens is the hydrogen adds to the alkyne, we get the cis alkene, and then we have more hydrogen add to the cis alkene to form an alkane. However, if we use calcium sulfate and quinoline, what that does is it coats the palladium and it slows down the reaction. What it allows us to do is isolate the cis alkene. So the reaction effectively stops at this point right here where I've got the mouse, and it won't go any further because there's too much calcium sulfate and quinoline on the surface of the palladium. Remember, the hydrogen has to add to the surface of the palladium. If you've got this stuff just coating the surface of the palladium, there won't be very many spaces for the hydrogens to add. So what happens is the reaction slows down and we end up getting just a cis alkene as a product. And remember, the reason it's cis is because all of this is adding to the same face of the triple bond. So we end up getting cis stereochemistry of our alkene, and that's a very useful way to make cis alkene compounds.